Standard 10 Maths 1 Problem Set 3 12th question. If the sum of the first p terms of an AP is equal to the sum of first q terms, then show that the sum of its p plus q terms is 0. Now in this equation it is given that sum of the first p terms, that is SP, is equal to sum of its first q terms, that is SQ. So SP is equal to SQ is given. Then show that the sum of its first p plus q terms, that is SP plus q, is 0. So this we have to prove that. And it is also given that p is not equal to 0. We'll use a formula for the Sn. Sn is equal to n upon 2 in the bracket 2a plus n minus 1 into d. Now from this formula we'll write the formula for SP and SQ. So SP will become p upon 2 is inside 2a plus p minus 1 into d. So in place of n we have written the p, and SQ will be q upon 2 2a plus q minus 1 into d. Now SP is equal to SQ, therefore we'll write this together. P upon 2 2a inside p minus 1 t is equal to q upon 2 square bracket 2a plus q minus 1 into d. Now it is equal to sign, so we can cancel this 2, or we can write multiplying by 2. So I'm just cancelling this 2. So whatever has left I'll write p 2a p minus 1 into d, that is equal to q 2a plus q minus 1 to d. Now I'll multiply by p to this bracket, therefore 2a p plus p minus 1 into d. Now to the q by q 2aq plus q minus 1 into d. Now we'll bring this thing to the left side of the equal to sign, therefore 2ap minus 2aq. I've written this here. Now I'm writing this p minus 1 into d minus q minus 1 into d is equal to 0. Now in this 2a is common, therefore 2a p minus q plus, from this d is common, so I'm writing d. We'll write it before or after. So this is p minus 1 minus q minus 1. This is common, and d I'm writing behind, is equal to 0. Therefore 2a p minus q. Now we'll multiply by p square minus p minus q square minus plus q is equal to d. Therefore 2a p minus q plus, now p square minus q square I'm writing p square minus q square minus p plus q into d is equal to 0. I've just written this minus q square and this minus p plus q. Now we'll write this together. This copy as it is. If we'll write, we can use the formula of x square minus y square, that is p plus q p minus q, and from this we'll take the minus sign outside, so it will become p minus q. Now in this, P minus Q is common, so that we can, so we'll bring this P, we'll take this P minus Q as common, therefore 2A P minus Q as it is, plus, now in this P minus Q is common, that I am writing P minus Q, another bracket, P plus Q is left over here, minus, nothing is here, so 1, square bracket D is equal to 0. Therefore 2A P minus Q plus, will multiply by D, this is P minus Q, P plus Q minus 1 into T is equal to 0. Now here we have two terms, and again this P minus Q is common, therefore P minus Q in the square bracket 2A plus P plus Q minus 1 D is equal to 0. That means, therefore, P minus Q is equal to 0, or 2A, this first term is 0, or this second term is 0, or P plus Q minus 1 to D is 0. But in the question only it is given that P is not equal to Q, because if P minus Q is equal to 0, therefore P is equal to Q. But it is given that it is not equal, therefore this is equal to 0. But P is not equal to 0. Therefore now we'll continue with this. Therefore 2A plus P plus Q minus 1 into D is equal to 0. We'll mark this as equation 1. Now we have to find out we have to show that S of P plus Q. So using the same SN formula, wherever n is there, we'll write P plus Q. So this is n by 2, it is P plus Q by 2. Inside the bracket 2A plus n minus 1, that is P plus Q minus 1 D. Okay. Now from the equation, this is P plus Q by 2. Now in equation 1 we have got this value as 0. You'll see behind. This is 2A plus P plus Q minus 1 into D is 0. The same we have got here. This is 2A plus P plus Q minus 1 to D is 0. So this is 0. We'll write from 1. So this is equal to 0. Therefore, S of P plus Q is equal to 0. This is proven. So answer. Therefore, the sum of first P plus Q terms is 0.